Hello and welcome back to the Canary Designs YouTube channel. This is the third video in a 3-part series. So in the previous 2 videos we've looked at how to make a digital U and building a digital environment, and in today's video we're going to look at putting both of those things together in order to simulate real life tasks in a digital environment. So let's jump right into it.
So just before we get into today's video, I want to quickly talk to you about the Human Interface Modeling process, also known as HIM. So this is the 3-part series which we've been putting together. The first 2 videos looked at building the digital mannequin and the digital environment, and the third video, which is this one, will look into combining the first 2 videos in order to simulate real life tasks in a digital environment. The example we'll be looking at today is a standard hard crane facility which I sourced online, and we'll be looking at 3 main things: identification of stakeholders and tasks, so who will be using the design and what tasks will they be performing; workstations and human machine interfaces, also known as HMIs, so this is not just a screen, which is a common misconception, but what are the points of interaction between the human and the design. And we will do some digital human modeling, looking at how to recreate the posture which a human might adopt when interacting with the design in a digital world. We'll be looking at 2 main tasks in this video: adjusting a manually operated valve and replacing scrap-up material in a container, and you can see the relevant stakeholder and human machine interfaces for each task on the screen now. One of the first steps I like to do is open up the step file in SolidWorks. This is why I would typically identify the human machine interfaces and gather the key dimensions of them, such as the height of the control panel or the height of the manually operated valve. An advantage of using SolidWorks is I also have the ability to use a sketch tool, meaning that I am able to gather measurements which might be more difficult to achieve using the measure tool. They are also all laid out on the screen like you can see here, rather than needing to note it down manually. Here's also this part of the process which we would check the compliance of the design with the relevant standards. In this example I have measured the height of the guardrail and checking it with the relevant standard, which is the BSI ISO standard 14122, and then repeat the process for any other relevant dimensions. So after we have got the fundamental measurements from SolidWorks, I like to jump into PowerPoint in order to recreate the key HMIs using basic shapes, such as circles to represent buttons, and squares and rectangles for screens and valves. Since they are created using the CAD measurements, they will be to scale. You can also correctly space them within PowerPoint so that the whole interface is to scale when you print it out, rather than nest them together like I've shown here. I have just shown PowerPoint here as it's the software which I have on hand, but you can use other software packages to achieve the same goal.
So once you've got your template completed in your choice of software, the next stage is to get them printed. I've got mine printed right in front of me. So since these are to scale, what it means is that once they're cut out, all the screens and buttons and all the valves are going to be the same size as they are on the CAD model. So what I'm going to do now is get them cut out and add a bit of blue tack onto them, and then I'll show you what to do in the next stage. So now that we've finished cutting out these templates and putting some blue tack on them, let's go find the wall and apply them using the dimensions which you measured in CAD before. So this is the area that we're going to be using to stick up all the cutouts we've just made. So for this I'm going to be using a tape measure, a steel ruler for smaller measurements, so between the switches and buttons, and some masking tape to outline larger areas such as the control panel itself. I've also got my laptop set up there, so that I can refer back to make sure the measurements I'm using are accurate. So let's get stuck in. So now that we have finished recreating the human machine interfaces which we saw in the CAD model across both of these walls, we've created a really powerful tool, because we can now interact with the design in ways which we cannot with CAD model. So a great example of this is if I look at the reachability and accessibility of valve 1 down there, I can look at the postures which I have to adopt in order to access it. So this could be one posture, or alternatively they could use this posture. But by having the human machine interfaces laid out around you in a dimensionally correct manner, you can test things like this and capture the postures. And you can also use it as a tool to make recommendations, so you can move these switches and buttons around and make recommendations based on that. And you can also use this tool to look at interactions such as this. So this is an oven up here, and this is the control panel for the oven. So by having an emergency stop down so low, when the user's taking things in and out of the oven, they might accidentally hit it. So all these are things that you can use this tool to capture. But it's also very important to remember not to design the design around you as a single designer, but just to use it as a tool to capture the postures and interactions they have with the design.
When you're trying to capture a body posture, whether to analyse or recreate in JAX, it's not just a case of getting a nice photograph of the body posture. It's always good practice to consider the use of anatomical planes, so I'll quickly talk to you about those now. Here is a diagram of all three anatomical planes. First we have the sagittal plane, which if you're looking at the body head on runs vertically down the middle, splitting it left and right. Next we have the transverse plane, and again if you're looking at the body head on, it runs horizontally across the body, so you have a top and bottom of the body. And lastly we have the frontal plane, and if you're looking at the body from a side profile, it splits it vertically down the middle, so you have a front and rear of the body. We use these planes to capture the posture, as it gives us a standardized method of doing so each time and removes factors such as perspective when analysing the posture and comparing them. What I've done here is recreate the posture which I created in the video and took a photo of the posture. The cardboard is only there to make it clearer where the floor is, as I am wearing dark trousers which blend in a little bit. But as you can see in this example, I captured the posture using the sagittal plane. And in this next example, I captured the posture using the frontal plane. And now that we have captured the posture correctly, we can start to recreate the posture in Jack, which is what we're going to do next. So this is a Jack scene which I have set up using the step file which you saw earlier on in the video. The process of building a digital environment like this was covered in the second video, so I won't go into it now. The only difference is I have added in a pink floor for this scene to make it easier to identify where the floor is. So let's get started by going to File, Open, and bring in the Gary mannequin. And what we are going to try and do is recreate the posture which we have captured. The mannequin came into the model hidden, so we just need to use the feature treat in order to unhide it. So now that we have the mannequin visible, we are going to try and get the mannequin into the posture to operate the manually operated valve down there. The first thing we are going to do is move the mannequin to roughly the right position, and then right click and select Control. The first thing to do is unclick standing, as the next posture the mannequin is getting into is not standing, and then click on the Predefined Postures box on the bottom bar. This is a bank of predefined postures which the mannequin can get into quickly. The one we want is kneel 2 knees and then hit apply. And you can see the mannequin gets into the posture straight away. The mannequin has shifted, we just need to move it back into the right position. The next step is to begin manipulating the hand. You can see that I am now positioning the right hand into a posture which was captured operating the valve, and notice that I am using all 3 axes in order to adjust the hand posture. And this is part of the reason why Jack is such a powerful tool. You can make really small incremental changes. It is also useful to have the posture you are trying to recreate open so that you can refer back to it. You can see that the hand is using the wall to brace in this picture which was captured, but there is no wall in the seam. So we will assume that the mannequin will use a unistructure in order to brace themselves, and we assume that the pipework is something inappropriate to use as a source of brace. So we position the left hand into the correct posture. So what I'm doing is just fine-tuning the posture, as the inverse kinematic in Jack means that the posture shifted slightly when manipulating the left hand into the correct position. So if we go to View now and create a view with the X window, this is another reason why we would want to use anatomical planes when capturing the posture, as we can now switch to the X window view and the posture can be easily compared between Jack and the real thing that was captured. So what I'm going to do now is fine tune the feet posture to make it more accurate, and then import some more mannequins in to show you the difference in posture which they adopt depending on their size. So what you're looking at here is a comparison of 4 anthropometrically different mannequins operating the same valve in a similar posture, viewed from the sagittal plane. I've added in a 10 cm grid as a reference for scale. So an example of this is if you look at the 5th percentile female, you can see she is 1 square closer to the edge compared to the other mannequins, which means she is 10 cm closer. So now that you have seen the process of recreating the posture to operate the manually operated valve and how to compare the postures across the target population, I'm going to quickly repeat the process for the second task of replacing the strap of material in the container. You can see the red section of material is the HMI for this task, and you can also see that I've removed some of the material around the area just to make it easier for you to view. If I bring in the 95th percentile male, you can see that he is able to easily reach the HMI location. However, when bringing in the 5th percentile female, you can see she's not able to reach the HMI. And it is only through simulations like these that you will be able to spot usability problems with the design. So we've had another busy video covering a lot of content, so let's end on a summary of what we have covered in this video, looking at human interface modelling, also known as HIM. At the start of the video we looked at understanding the design, which covered who you're designing for and what tasks will they be performing relevant to the design, and are there any relevant regulations and standards to the design which we need to look at. And we ended this section by looking at human-machine interfaces, what they are and how to identify them in a design. The next part of the video covered simulating and capturing postures, in which we used different tools in SolidWorks along with PowerPoint in order to create a scale, low fidelity prototype of an identified human-machine interface to interact with, and we looked at how to capture the posture using anatomical planes. And in the last section of the video, we looked at simulating real-life interactions in a digital world, which looked at adjusting the mannequins to the correct posture when interacting with certain aspects of the design and comparing postures of the target population using different sized mannequins. We hope you've learned something in this video, and thank you very much for watching, and we hope to see you in the next one.